Yeah, actually, because that protocol is too slow. So,
Yeah.
because as far as I have known, this one's really new design. So normally it's must use the new protocol. If you use the short protocol, it's really slow and it's outdated, right?
Yeah. So this is an application. This is it's a reference application to have the basically to control DERs using the SOAP server. So this one is an application using the GrabsD API and working with the SOAP API to connect with the devices. So this will give you an example of if you have an application that is already working with SOAP, and then you want to connect it with GrabsD. So what should be done?
That's the reason. That's been you just open more protocol for any old application. It still work with the old one. You mean that?
So it's kind of having a wrapper around that. And
yeah. I see.
Okay. Okay. Going back to this one. So basically, the primary. I can give you one thing. So this is the training document for GrabsD. It starts from installation and gives you, in some cases, a step-by-step guide on how to do what you want to do with the platform. But I can't put this link in this both link in the chat.
What does it mean with the D? This is dim. This is dim. Like DERM.
Distribution.
Distribution.
So GrabsD was primarily developed for distribution network, though nowadays we are, from this year onwards, we are working on including the transmission into the picture. Yeah. And apps, because it's a platform which you can use to develop more standard-based applications for distribution networks. So. Okay. Okay. I think I need to share a different screen now. This one. Okay, so you should be able to see a terminal now. Are you able to see the terminal I'm sharing? Hello?
Hello?
Can you see the terminal I'm sharing?
Yes, bro.
Okay.
Yes, we can see.
Okay. So, so the first repository that you would basically clone is this grabsd-docker. Reason being that the grabsd is installed using Docker. In my case, I'm using Docker desktop, and then it is will be installed using different Docker containers. So all the containers are available on Docker Hub. This particular repository has all the helping scripts and all the links provided so that it can download those containers and set up them correctly. So I'll go here, and if you clone this repository, you will see there is a run.sh script. So I'll say run.sh. You can provide an optional tag. In my case, I'm doing develop. Let's see, I don't have any. Okay. So once you clone this, you will do run.sh, and you can optionally provide a tag. And this would start downloading all the different containers. So as you can see, there is a Viz container, which is a web-based visualization application. There is a Proven, which is there for the time series data. Blaze Graph is a graph data store that we are using for storing the distribution model. So one of the things that we did at the start of GrabsD is, instead of using a traditional SQL-based data store for storing the network model, like most of the utilities that they're doing, we went and used a graph-based data store so that it would help in understanding the common information model and to make it a more standardized API. InfluxDB is again for time series data store, and then GridAppsD is where we have the core platform. MySQL is for logs, and sample application is a Python-based application that is a very dumbed-down application. I'll show you what it is doing. I took a name common information model, but I don't know if you guys have already talked about it or not.
May I know that how many megawatts that the system have handled, or how many sites or the the energy plant has connected into the system? Because when you mention about MySQL, the database that you have used the system, I'm a little bit doubt in terms of the volume, the size of the storage that you can handle. It's also about the performance, because it has some limited, I'm sure that somewhere inside you have to use NoSQL to use the it's like intermediate database in order to receive the signal before you proceed the data and put into MySQL, right?
Yeah. So for MySQL, we are just using it for the log messages, but the APIs are written in the way that you can implement basically any data store that you are using. So what we have done is we have a log manager API and then a log manager implementation. So that implementation can basically extend that API and use any data store that is needed. So in our case, we are using MySQL, and the amount of data that goes in. So you can think of it as the highest frequency thing that we do is probably running a simulation as fast as possible. So it can handle up to that, and then but you can use the implementation to just change it. So yeah.
Oh, okay. Just because for quick demonstration, so you use the MySQL for that purpose, but for the real application, I believe you use another one. Is it right?
Yeah. So either you have to create a buffer. So what frequency are we talking about here?
Sorry.
So what frequency and the amount of data are you thinking about in processing to put in SQL? Because we are not putting the measurements itself, so that's not going into SQL. So it's only log messages. So if we,
okay.
Yeah.
I see.
So for time, so the device measurements, they are going into the time series data store.
Okay.
They are not going in logs. So logs are basically, the application has registered, it has started, simulation has started, it's going into this time step now, and it's completed, the application has stopped. Those kind of things are going into logs.
Yeah. I see.
Yeah.
I see.
For measurements, we are using Influx. So, yep.
Okay.
Okay, so before I start the platform, let's open another terminal and see what we have done. So if I see this, so all of these containers are now running. Once you install GridAppsD, there are like 1, 2, 3, 4, 5, 7 or 8 containers running. Okay, so after running the run.sh, the script run.sh will automatically take you inside the GridAppsD container, which is where is it? This one, where the core platform is. So now you go here and you say run GridAppsD. So start the platform basically. Give it a couple of seconds. So what's happening behind the scene is the platform is figuring out, okay, how many distribution models I have, and are there any services and applications currently registered to me, and all those fun stuff.
Purva, sorry to interrupt. Can I record this session? Is that okay?
Yeah, sure.
Thank you.
Okay. So now let's go to our browser. To browser, where is it? Okay. Let's go to localhost 8080. So as I said, one of the Docker containers that got installed and started is the visualization application that is available on the localhost 8080. The default username and password are already there, so I'll just log in. So when I log in, I will see these menu items. So the first thing usually an application developer does is to start a simulation so that they can test their application with it. But if you have any questions before, then I can go over it before we move on to a simulation. Okay. So then the default distribution network models available within the system are going to be shown in this power system configuration. So there are different variety. You want a large model, so we have IEEE 8500 or a 95 or modified version of it, which is a 9500. We modified it by adding more DERs, and then I think we proposed this to IEEE, and it is now a valid IEEE 9500 model. And if you go to a medium-sized one, we have 123 and 123 with the PV, and then small is IEEE 13 and some variations of those. So let's start with medium, so we can also see what's happening. In next tab is the simulation configuration. So as I said, for the log manager, same thing applies for the simulation as well. The platform contains a simulation manager API. Any simulator that you want to connect with the platform, you have to implement a simulation manager IMPL and extend those APIs if you want a different simulator running instead of the GridLab D, which is there by default. So I know it lists Ochre here, but Ochre has just recently become an open source container, so we have not yet integrated it in our installation version. We'll do that now. But yes, if you had the permission to run Ochre beforehand, you can run Ochre or GridLab D. I'll start the GridLab D. So by default, the duration is 120 seconds. You can change the start time. You can run real time or faster than real time with this check. In real time, the GridLab simulation runs every 3 seconds. So you will have a new measurement every 3 seconds. And faster than real time is however fast that simulator can run that distribution network model given the parameters, and then measurements will be produced as soon as possible. The time step would still be 3 seconds, but you will get the measurements much faster. Then there are a couple of parameters that can be changed, like for example, what is the load variation that you want to use. You can specify this here. So a couple of fractions, whether you want to use houses in the model or you want to run without the houses. And then application configuration. So the way registration for application happens is application run their own Docker container, but whenever the container starts, it finds out if the platform is running, and if so, it registers the application with the container. So in this case, we have a sample app container running, so I'll just select it. The platform has the ability where you can introduce some events into the simulation during testing. So these kind of things come into picture where you have an application where you want to see what would happen if there is a fault in the system. How would my application react? So you can select fall and select what type of equipment you want fault, what kind of fault should it be, when it should start within the simulation, when it should stop, and things like that. You can introduce communication outages where your application is sending the command to control something, but it's not happening because there is a communication outage, or there is a output outage where measurements are not reaching the application. How would the application react in those scenarios? or there is a schedule command where within the simulation something changed in for a device. So how the application would react. Those kind of things can be configured here. Service configuration, I would not select anything for this demo, but by default, we are starting GridLabD, which is registered as service, and Helix, which is a co-simulator. Okay, let's submit. So now this visualization, which is also kind of an application, is sending the request to the platform saying, okay, give me all the details for the IEEE 123 model, how to display it, what are the equipment, what would the measurements look like. So by default, the visualization creates these two plots, load demand and average max voltages, but you can also create your own plots here saying, okay, I want to plot the magnitude for power for line 30 for phase A, and done. So that plot would be here. And let's start the simulation. So if you see here, scroll down, these square boxes are switches, and there are capacitors and other things also somewhere. See, there is a regulator here, and so switch which are open is green, close is red. Okay, so then we started the sample app, right? So sample app every few seconds opens and closes the capacitors. So that's why we are seeing the alarms here. It's a very dumbed down application. It doesn't do any logic in opening and closing them. It just has a example of showing, okay, if you have an application which is opening and closing something, this is what it would look like. So every few seconds you will see this alarm saying, okay, this capacitor, this equipment by this user was opened. This is app user. So you can acknowledge it, okay, that's fine. Or you can use the locate node and say, okay, this was the capacitor that was opened. So it will take you back to the network model. Okay, there are voltage outages, regulator things happening here. These are the log messages that are going into MySQL. If you expand on them, they will tell you the source, the process ID, and all those fun stuff. And this is the all the plots here. Any questions on this?
The simulation application that you are doing here is what is the business case is handling for?
Sorry, say it again.
The simulation, right? The application that you integrate into the Adms during the demonstration. So what is the business case that the simulation work for?
What is the business case?
I mean that the purpose of that system is to,
Yeah, so this simulation is basically we provided the GridLabD with the IEEE 123 distribution model and say that, okay, given this load profile, start at this particular time and run it for 120 seconds. It does not have any specific purpose other than showing it for a demonstration. So for different purposes, you can use different type of, based on what we are working on different projects, that's why I'm giving you the examples. Some of the simulation are working more towards for weather forecasting, where we start a simulation for a specific weather event and have some weather forecast included into the simulation use case and run it that way. Some example want to have particular load profile where they want to make that, okay, at the night time the car would be charging, some other devices would be charging at the home. In the day, the load would go down, and those kind of things. So they are playing with the load profile and see what is happening. So yeah, there would be different use cases, but in this case, this is a very simple example where we are saying, okay, given this sample load profile where and an application which is trying to open and close something, run this simulation. That's it. And that reminded me, let's go here. Yeah, this is the sample app. So this is a Python-based sample application, but the source code is right here. Sample app, run sample.py. If you have to
any application like mirror management, that means, for example, in mounting that great. Okay, the mirror, the consumer will each consumer will have a specific mirror. So if I have one system to manage all the mirror already, right? I want to integrate into the Adms, and another system I have another purpose like a billing, because I manage the client. I just want to make sure that I manage all the billing at different time slots. Okay, and I want to integrate into the apps. I want to integrate into ADMS. Is it the good business case? The good use
okay,
case?
so you have two simulators and you want to co-simulate it. Is that the case? One the distribution side and one is the building side.
Yeah.
Okay. Okay, so in that for that purposes, not specifically one distribution, one building, but the Ochre simulator that I was talking before, their use case was they want to run the distribution system in GitLab, but they want to run the houses in Ochre. So Ochre only simulates houses, and GitLab they wanted GitLab to simulate everything else. So in that case, what happened is we using, as I mentioned before, using Helix as a co-simulator. So that's the whole purpose of using Helix. Helix maintains these two simulators with different time steps. So if the Ochre is running at 50 minutes and the GitLab is running at 5 minutes, Helix take care of that, and we can provide the communication between the GitLab and the Helix. So yes, the co-simulation, we have done that, and one part of the equation and the other simulator is doing another, and they communicate, because when you're doing houses and distribution, there are certain load points which you want to communicate between both of those, right? So the communication part was also there, and then the applications can subscribe to the overall measurements or just one of them and work up that way.
Yeah, something like that.
Yeah.
And normally the ADMS have to connect with the SCADA array to ensure that because in the mini grid normally we must have a main transformer, right? The main transformer must be controlled by SCADA, something like that.
Yes.
So that's mean from the production, then it's grid will send to the consumer, right? In between, we have a management team. They also do some other tasks to do some management business case. So that's it. If we have a short demonstration, it's perfect. Everybody can.
Okay, yeah, makes sense. So yes, we did those kind of co-simulations before, but the communication between those two is happening via Helix co-simulation. As such, we don't have any manual interaction in between the co-simulations, so you can that way unless you send a control command for a device. So, but yes, the co-simulation is certainly possible if you have a building, a house one and a distribution one. Yeah.
Because in the real business case, normally, the business, they have a direct integration already, right? That it could, the IT department normally have to maintain so many connections among the application because they don't have something in between in order to route the data into the applications destination of the use data. So somehow, if we want to restructure the architect, we have to do step by step, right?
Yeah, that's the
from there. You have to have a platform, and then we connect at least 2 points first, and then we have to disconnect another connection and connect into the distribution system and then route again. So that is one way, step by step, to restructure the whole application architect within an organization.
Yeah, so that's why I was showing you this sample application. This sample application works with IEEE 13, 123, 8500, 9500, or basically any graph-based data is common information-based data format. It doesn't change. You can run it with any model. Reason being, we are using a standardized data set and a standardized message structure. So if I go here and select another distribution model and make it run with that one, let's say I select IEEE 13 and sample app, that way it would work the same way, because that was the point of using the API, because otherwise if you have a specific implementation for a specific network or a specific vendor-based API, which is not standardized, or a direct connection with a utility devices, then for every update, you have to go through the same process of updating all the applications and all the services and all the interaction points from start.
Exactly.
So right now I'm running the same application with a different network, and it's still working. So that's why we chose the common information model, and we have people within the GitAppST team and within the PNNL organization who are active members of the SIM users group, Common Information Model Users Group, and for any new feature that we network, we also propose it to the user group and add it to the model, so that it becomes a part of this standardization rather than we coming up with a one-off solution to achieve something.
Yeah, that's great.
Any other?
Any single diagram that reflect the connection, like a visual way to have the people, non-IT people can understand it into that singular diagram.
So what specifically the APIs, or
maybe
it's not really API, but what I mean is that in terms of the to me, it's a kind of messaging system. This means, it's kind of data servers in between and connect with all the application around, right? So when we integrate any new application into the ADMS, we may reflect it in a visual way to control the visual to say, okay, currently the IDMS already connect with 3 or 4 application already, and it can look like this and like that. Understand? With the visual way, with real support for the non-IT people, they can see, it can manage or can easy to manage even for IT people.
Okay.
You don't have the connection as it is in the.
Yeah, I understand. So, so as a ADMS platform, GrabZ can do a lot of things. So currently we can even do distributed applications. This one is like centralized, you get all the measurements, right? But in real world you have distributed, so we can even support distributed applications. Being that our primary focus was to develop the platform, and then anybody can take the API is the communication that they receive and develop their own visualization. The only purpose of having this one is to give demo like today, where we can show, okay, what is a bare minimum, what is happening on the platform. But visualization was never really like the goal of the project. So all our application and services are basically Python based, where they're doing their analysis and they're storing the data in the data store, those kind of things. So I understand when what you are expecting is like a visual way of saying, okay, if you want this part of the application, pull this in. If you want that part, pull that part in, and things like that. So unfortunately, we don't have anything like that. What we do have is like a training material. For example, it's a GrabZ application structure here, where it says, okay, if you are creating a Python application, this is the first block you will be doing. You can query the model. This is how the model is coming to you. And now this is the sample code that you can. So what's happening with some documentation, and we have a team which can help you understand that as well. But we don't have a visually integrated component in this application which you can pull and create an application.
Yeah. Just need time. Need time. Okay, that's great. You said that you used to integrate with the building system already, right?
Which system?
Building system. Integrate this one with building system.
So yes, so Ochre is I think Andrel developed simulator that works with houses, but you can also simulate is a Voltron, not particularly simulator, but what other? So yeah, we integrated with Ochre, but that was for that particular project. So in general, we don't have that by default, but we developed it for that particular project. So yes. But yes, in the simulation, when we selected this one, where is it? So you can say use houses true, and whatever houses are available in the model, the GridLab simulates that. Yes.
Hey Purva, if we don't want to use the simulator, can we show that too? Like if we have live devices or something, our own setup.
Oh yeah. Do you want to take that with DNP3 or?
I don't have anything on my system right now. Maybe you can quickly show.
Are you thinking DNP3 or distributed?
Distributed in general, like
okay.
Yeah.
Okay.
I think
sure.
I'm just trying to understand if they want to implement on their side, then how. Yeah.
So yeah. So far we have seen more of a centralized applications where you have the measurements for overall all the network, but in real life you may not have those kind of availability to access the data. So what we have done is, hold on, let me first show you a image, and then I'll go show you the code. Okay, let me know when you can see the image or the PowerPoint I'm sharing.
I can see.
Okay.
Yeah.
So what we have done is, so far, this is what we were looking at, the centralized application, which is connected to the distribution message bus, which gets everything, right?
Yeah.
But
Yeah.
in real world, your network would be divided. So the way we have divided this is, first, the network may have multiple feeders. So there would be a feeder message bus. So any application at the location of that feeder bus would only get the measurement for that feed, the device is connected to that feeder bus. So for example, switches and LTC, it will get the measurements from those. And then each feeder has specific switches. So then the next level is divided into switch areas. So the next area, this distributed agents are connected to individual switch areas, and they will get the measurements from, let's say, this purple capacitors and any other devices connected to the specific switch areas. And then there are distributed agents connected at the secondary building houses level, where they will get the measurements of devices connected into that secondary areas. So in order to demonstrate this, we have this sample distributed application. As I said, there is no visual component to show that right now. Oh, okay. I think I
Sorry.
switched.
Yeah, you're sharing slide 3. I'm sorry.
Yeah. Can you see the GitHub page now?
GitHub, yes.
Okay. So in order to demonstrate that, as I said, we don't have a specific visual component to that, but there is a sample distributed application. So what it does is it's whenever you start this application, it creates all those different agents. So at the feeder level, at the switch area level, and at the secondary area level. And in this on measurement function, they will receive their own measurements. So if you have a use case where you want to mimic a more distributed application, you can basically take this and modify this on measurement function and see how your application does in a distributed environment where they have the measurements of their own devices. And then it also has the capability of talking up and downstream. What I mean by that is that this agent can communicate with this one. So there are many times a use case where you want to send up the aggregated data. That, okay, I can communicate with our devices, but let's see the aggregated load looks like that. So you can send it upstream. And if there is anything wants to go downstream, you can send that message as well. So those kind of features are available in this application. Yeah, so yeah, this is a Python-based application. You can run it. It's working. There is README associated with it. If there are any questions, feel free to send me an email. But we don't have any visual component to it. One thing we have also done is previously application developer have to write Sparkle queries to get the data, but not every electrical or software engineer know how to write a Sparkle. So we have created a sim graph library, which allows you to just say, okay, for my agent, give me all the line buses, give me the line impedance, and basically everything you can, from the network model, you can just call it as a function rather than writing queries. So having the knowledge of Sparkle queries is no longer a requirement. So even if someone is not a software engineer and they want to explore the model, they can do it.
Thank you, Baba. And I think Lochana and many of them are working with SCADA system. So for SCADA system, I think we have the DNP3 service, right? Or I asked them how they can integrate SCADA. So did we cover that part? I'm sorry if I missed that.
So how to integrate DNP3?
No, I mean, yeah, just I think I showed them the conceptual diagram where we have the basic one where how we can integrate the SCADA system, but maybe just did you close the system? If you show on the visualization, okay, this is the service. Sorry, I'm not having the VM set up right now.
Okay, so that is so one part of the distributed architecture is a device interface. So device interface allows you to interact with either emulated or real devices. So basically you can connect with a DNP3 or a 2030.5 device. You can send the measurements to the application using the GridApps API, or you can receive the control command from the applications and send it to any device. Currently, we have, as an example, DNP3 and 2030.5, but it can be extended to implement any other device protocols as well. For DNP3, Alka is a good resource. She has worked on that for DNP3 as a master or an outstation. For 2030.5, we have Craig Allward on the team. He's working on that one. But yeah, that's what you have.
Thank you, Purva. So anyone has any questions related to how we can implement, or please feel free. The end goal is we have to work on a topic or a project where we can show that okay, we are going to integrate ADMS. Let's say we cannot implement directly because we have only 2 months. December is the final presentation, so maybe we will come up with the plan. Okay, this is the since we are working with different countries and different countries have different architecture and different grid system. So we were thinking if they can implement this in future, that will be nice. And for example, Luchana came up with SCADA system, and then I think Ms. Anna wanted to know more about PB integration and how we can also integrate the billing system. And I mean, how ADMS can improve the billing systems. We wanted to know that too. So this is helpful. I am right, Ms. Anna. Did I miss anything?
Do I miss anything?
I think there is a question from me.
Yeah, I just read that. How to start from the basics to understand all the code in the GridApps. I would say go the other way. Instead of understanding all the code in GridApps, it would be beneficial to know what you're interested in. If you are interested in having that as an ADMS system, so let's start from what feature of ADMS interests you first. So let's go from there, because GridApps itself has the model data, the simulator, the log manager, the device interfaces, the distributed system. A lot of things are going on behind the scene. This is our, I think, 8th year now. So to understand what we did in all 8 years and take everything in could be a lot. So let's start from, okay, what are the features that primarily you are interested in, and let's go from there. I would say the training material is a good thing to start from. It shows you different components of the platform on a broad level and gives you one topic at a time to understand what's going on. But even if there is something which it does not address, you can send out an email, and we'll be happy to respond. We also have a forum and for issues as well as for discussion. Let me put that in. So that may even be better way of engaging. This is a discussion forum, the link that I just sent on the chat. So basically, we have a lot of people working on GridApps. So some may have expertise on the data side, some may have expertise on the API side, some may have expertise on the device interface side. So if you put a question there, appropriate person would respond with the more clear answer. And then if you run GridApps on your local machine, and if you see there are any, you are facing any issues either in running, or you think there are any like errors that are happening on your local system, this is the issues forum. You can put the new feature request or a bug issue there as well, and we will respond to that. How to test the code in the
In the training material, it gives you the guide of how to install it, then run the visualization, run the application and the simulation. That would be a good way to test if the installation is correct, if you can run the simulation end to end. But in terms of if the goal is to run a device interface or a distributed architecture, then let us know and we'll guide you there. There are README associated with all of those, but we can point you to the right direction.
May I ask one question?
Yeah, sure.
Is it possible that I can integrate Adms with one data warehouse I put on the cloud?
A warehouse.
Data warehouse.
Data warehouse.
Data warehouse.
For example, I want to design a data warehouse on the cloud, and I to retrieve all data of all the site on every region from in my country, for example, right? And I should build that data warehouse specifically, right? I don't store each thing in each type of application. I want to build a data warehouse for myself, right? Is it possible?
Yeah, so what all data are you thinking about including in that data warehouse?
Data warehouse, it could be, how many generations that field, that plant have created, generated daily or
Oh, yeah. Okay.
something
Yeah,
like
yeah.
that.
Yeah,
And
so-
I also want to store on the information of the consumer and the use, the volume that the consumer have used, everything, right?
Yeah.
The transaction and also the quality of each renewable energy too, like rooftop. We need to check about the PR, the quality of the PV panel or wind plant. I will check something related to the speed of that region, for example, right?
Yeah.
I could store all those things to data warehouse because I could do something, extract the data later or something like that.
Yeah, so I think you can certainly do that. You can create an application which is consuming the data coming on from the ADMS, and then you can putting it into the data warehouse. And
Okay.
in between that in that application, you can also add some of the analysis, like you say, quality. So the ADMS will give you the measurements, right? So you can create an application which also checks the quality of the data. So
Okay.
then you can associate, okay, the quality is not coming good or things like that. You can also mimic those qualities if you want to say, okay, let's change the device in certain way where we will mess with the quality, and then you say, see, if the quality is not coming right, my application would detect it and then store it into the data warehouse. So yes, you can certainly do that. And then the Blaze graph already has what equipment is available within what network model, so you can also query that and put that into the data warehouse in more.
I see. I understand what you mean. Yeah. Okay. Okay. So, what is our next step, Ms. Hanka? So many work, I think.
Yeah, next step is now we have grid after demo. We need to figure out how do we want to implement ADMS.
This is so many things because right now, we don't have a real application yet, right? Most of the application that Miss Sharma demonstrated on the simulation is hard for the attendants in the meeting to understand what it is. So we try to do something, easy for them to understand.
Yeah, we can try all the instructions that Ms. Purva has shared and then let us know if you have any questions, and then we can come up with something. So this is October. Let's meet another time, and then we can discuss how we can implement and how we can come up with a common topic that can be used for all the participants.
Okay.
Right?
Okay. Yeah. Okay, that's good. Thank you so much, Ms. Sharma. So I can understand a little bit better, right?
Me too.
Okay. Thank you. Thanks,
Thank
everyone.
you so
Bye-bye.
much. Thank you so much for
I
your
believe
time.
Thank you. Bye bye. I believe that our team will need your support so much, a lot of, your support from the near future about the protocol, about the coding, about something like that. Without you, we cannot finish the pilot. Miss.
Okay, we have a question. I'm curious about how the grid communicates from one system to another system, like when one country export from country to another country. Export the energy?
I think so.
I may not be the right person to answer that because I have not worked on a use case with this one.
That's a good question.
Good question. Yeah, I don't have a good answer for you there, but I will ask around and see if I can come back with a better answer.
Maybe
Great questions. Because right now Vietnam exports so much energy to Cambodia, right? Right.
Yeah, there's a lot of power trade.
Yeah. And Vietnam also import the energy from other countries too. Because each region in Vietnam, some place we lack of energy, but some region we have more energy. So that means we have to buy the energy from one country, but we export the energy to another country. Because Vietnam is long, the grid is really long, and we cannot, transmit the energy from one place to another place with a very long distance, because it's loss, right? The loss will happen too much.
I think you know this problem well, because in EVN SPC we sell electricity to Cambodia in An Giang and Tây Ninh province. Yes. So for the technical issue and technical matter, I think Nhung will understand well.
Yeah. So we have to ask her.
Okay, sorry I have to run now, but thank you everyone, and feel free to post your questions on the discussion forum and create an issue if you find any issue in installing or running GridAppsD, and I'll be happy to help you.
Yeah.
Thanks everyone.
Thank you so much.
Bye-bye.
Thank
Bye.
you.
Thank you.
Okay, so we will talk soon. Bye.